Okay, in the last lecture we had some discussion on the screw axis. Today's lecture we will now look at glide planes in our 3D space lattices. So, in an earlier lecture we had introduced a glide plane of this kind, where the glide is represented by this symbol. So, it starts out like a mirror, and then this arrow indicates that the glide direction is the B direction, and the glide magnitude will obviously be, since B is a lattice translation, the glide magnitude has to be B by 2, and this particular space group was referred to as P 11B. Now, let me just consider this in a this thing. Let us take different case. Let us assume that we have orthogonal axes A, B and C. You have, okay, this is A, B and C is normal to the AB plane, and I have a B glide indicated by this symbol. So, this is called a B glide, indicating that the glide direction is B. So, if I put a motif at a point above the plane, the glide plane will reflect this motif below the AB plane, change the handedness and then translate by B by 2 to bring it here. Handedness changed, and this will be put as minus to indicate that the motif has gone below the AB plane, and then again reflect up, and then again a glide translation of B by 2 will bring the motif here, and of course, this motif and this motif are related through lattice translation B. The lattice translation A will bring all of these motifs out here. Now, this is a figure that I have drawn. You can imagine that this is basically the projection is along C. Along the C axis, and here I should say that tau equals B by 2. Now, same thing B glide, but let us say we change the projection axis. Let us say that we take projection along A. If I take projection along A, so I have to be careful about how I draw the axes. So, in the plane, then I will have axes B and C, and A axis will be coming out of that plane. So, we can call this as B vector, this as C vector. So, this is my origin here, and out here of course, we already know that this is the origin. So, A vector is normal to the BC plane. So, you have changed the orientation in which we are trying to look at the same thing. We still have the same B glide. Now, where is this glide now, because the glide orientation has also changed, and where would that glide be? Well, glide is in the AB plane. So, I have A coming out. So, glide still remains in the AB plane, but now which means that the AB plane is perpendicular to this figure, perpendicular to BC, and therefore, the glide plane itself is perpendicular to BC, and the glide plane is parallel to AB. So, I should say glide perpendicular to figure. In this case, it was parallel to the figure, and glide is parallel to AB, which means that the glide would be, let us say that this is my glide. Now, I have drawn this by a dashed line now. Now, this is the same sketch or same graphical symbol we were using for glide in the plane groups, where the glide would only appear in basically in one orientation. So, always it will appear as a dashed line. So, this dashed line is indicating that the glide plane is perpendicular to BC plane and the glide direction is along B. So, the glide direction is this. So, this is my glide direction. So, with this in mind, let us put a motif here, reflect across the glide plane and then translate by B by 2 and it will remain above the plane. Reflect and translate and you can see the change in handedness. So, if this is 1, 2, 3, 1 goes to 2, the handedness changes, 2 goes to 3, handedness changes, and you can also see that 1 can go to 3 through a lattice translation of B. So, this is how the same space group will look like this. How about taking another view? Let us say that now we do a projection along this time. Let us do a projection along B. This was projection along C, the first one. So, now the third diagram. First, let us get our axes correct. In this case, the axis C and axis A is here. This is my origin. Now, one should note about the axis selection. Even in the previous case, we are following a right-handed system of axes and we must keep that same system. So, by putting B axis here, C axis here and origin here, we have the same axis system. Here also the same thing, C here, A here, B will come out. Now, the glide plane is the AB plane. Now, B axis is coming out, A axis is in the plane, which means the glide plane, as in the previous case, is perpendicular to the AC plane. So, glide plane, let us put it this way, glide plane, glide perpendicular to AC plane. But what about the glide translation? So, glide translation is along B and B is normal to this figure, which means the glide translation is also normal. So, how do I indicate a glide plane? By just looking at the figure, one can make out that that is the particular glide translation, that orientation of the glide translation should be such. Well, this would be indicated instead of a dashed line, this time a dotted line would again indicate a glide plane, but this time the glide direction is normal to the AC plane, which means the normal to the AC plane is, so glide translation tau is perpendicular to the AC plane and along the B axis. So, if I now let me put how the motifs will look like in this perspective from this viewpoint. So, let us put a motif here above the AC plane, it will reflect through the glide plane and then translate it along B, and along B means it is going up. So, this would be indicated first of all a handedness change and it goes up by half the lattice translation, half of the B vector. The lattice translation now will take both of these motifs out here. So, all the three I have drawn, all the three are basically referring to the same glide plane in the same setting. these different perspectives how to display this, because once we know these perspectives, then we will be able to read the international tables. Now, similarly, as there is a B glide, in this case we are talking about a B glide, we can also have A glide, which means the glide direction is A, or a C glide. You can try drawing, as a practice, you can try drawing these sketches with the A glide and C glide. Now, there is something called as a diagonal glide. Which is also called as an N glide. So, in this case, the glide translation is along the diagonal of this AB plane. Hence, tau would be, the glide translation would be A by 2 plus B by 2, and the glide plane itself is the AB plane. In this case, if I put a motif here, it gets reflected below and then translated along the direction A by 2 plus B by 2, which would bring this motif somewhere here with the changed handedness, and it will be below the plane, so therefore minus. So, this one again, as you can see, this is projection along C. Now, let us take a projection along B. So, projection along B, let me draw this. Same diagonal glide. So, basically I have the AC plane in this case, and the B vector is normal to the AC plane. Now, where is the glide plane? The glide plane was in the AB plane, which means the glide plane becomes perpendicular to the AC plane. So, in this case, glide is perpendicular to the AC plane. And what is the glide direction? The glide direction tau is A by 2 plus B by 2. It's the same system we are looking from a different perspective. So, A by 2 plus B by 2. So, A by 2 and then B by 2 coming up. So, first of all, how do I represent this glide, which will clearly tell me that the glide direction is going to be actually neither perpendicular nor parallel to the AC plane. You can clearly see the glide direction is neither perpendicular nor parallel to the AC plane, but it is at an angle. That is indicated. So, it is in between the dashed line here in this case, or the dotted line here, dotted line perpendicular, dashed line parallel, it is in between. So, what we do is we draw a glide with dashes and dots. To indicate a glide plane in this manner. Let us just take a motif, reflect across the glide plane, and then so we reflect and so it goes A by 2 and then b by 2 up, which means it will go half plus, and then finally reflect back, handedness changes, and we come out here. So, this is the kind of pattern that we make. So, I should write here that glide in this case, well, all cases is parallel to the AB plane. Now, one final example of a glide which is called as the diamond glide. So, the diamond glide is also called as a D glide. So, here let us say we have the glide plane, which is the glide, this diamond glide is parallel to the BC plane, which means this glide is perpendicular to the AB plane. And the translation vector for this glide b by 4 plus c by 4. So, to represent this glide, we represent it by arrows and dots. To get this glide plane like this. Now, if I put a motif, reflect and move now b by 4 horizontally and then c by 4 vertically up. So, handedness changes and we move 1/4 up. So, 1/4 plus, reflect again. So, handedness changes again and then move 1/4 up again. We come here and since we have moved 1/4 up again, this will become half plus. Now, reflect, handedness changes again and we move to this position, handedness has changed and another 1/4 added to half would be 3/4 plus, reflect and then we come back to this position. So, this is the way the pattern will get generated because of the diamond glide. So, this in a nutshell is a summary of all the glides that we will encounter, and then finally, I will take a few more examples of space groups. Now, we had seen in the earlier lecture this particular space group P112 sub 1, where in this case this is A, this is B and the C axis is the unique axis. So, where the 2 sub 1, the 2-fold screw axis is parallel to the C axis. So, C axis is unique. Now, lot of times you will find that this particular monoclinic based space groups, sometimes the B axis, very often the B axis is chosen as the unique axis. If this was the case, so if I assume this is the same, so I get P11 2 sub 1 when the C axis is the unique axis. Now, this same space group symbol will become P1 2 sub 1 1 when B axis is unique. So, let us consider this with taking B axis as the unique axis. So, in that case, so here 2 sub 1 is parallel to B. So, this is C, this is A, and the B axis is perpendicular to the AC plane. So, this is essentially this is a space group based on the monoclinic lattice. So, taking this, it will actually have the same diagram as I had drawn earlier. So, so I have this space group, two-fold screw axis is distributed in the cell as given. So, if I put a symmetric motif, rotate, the screw axis rotates and then translates by half up, and then the lattice translation takes this. So, this is how the pattern would form, and you can see that this particular motif and this particular motif are related to the central two-fold screw axis. Now, this is what would be P1, 2 sub 1, 1, with B axis being the unique axis. But now consider a different orientation. So, B is perpendicular. So, BC plane is a rectangle, AB plane is also a rectangle. So, let us do a projection such that the BC plane gets projected So, I have the B axis here. So, project along A. So, the projection is along A. Now, if you look at the C axis is at an angle to A. So, C axis will get projected with a different length. So, we have to indicate that by simply writing CP, C sub P, P meaning it is a projected axis along and it has been projected along A. Now, where is my two-fold rotation symmetry, my two-fold screw axis? So, the 2 sub 1 screw axis, as we said, is parallel to the B vector. So, that means now it is in the plane of this figure. So, how do I indicate the screw axis now? So, this is indicated by so, you will see 3 screw axes in the plane of the figure along the edges and thus in the center. Now, if I put now a motif, it rotates through 180 degrees and then translates by B by 2. So, rotates through 180, translates by B by 2. Now, this 180 degree rotation will bring it below the plane, there will be no handedness change. Then again rotate through 180 degrees, comes above the plane, again another translation will bring the motif out here. Translation will bring these motifs. In this fashion. So, this is the way, the same P1 2 sub 1. So, this is also P1 2 sub 1 1 space group, but with a different viewpoint. The projection is along A. In the previous case, the projection axis was the B vector. Now, consider another one. Let us consider the plane group of space group P1 C1. Now, what does this mean? This is again monoclinic only, primitive monoclinic. C stands for C glide, which is essentially perpendicular to the B axis. So, B axis becomes again the unique axis. So, if I look at when my projection axis is B, this is a C glide. So, this is C, this is A, B is perpendicular to the AC plane. So, B is perpendicular to AC. So, it is a C glide, which means the glide translation is along C. Show it as a mirror and then put an arrow towards the direction of the translation. Then I can put motifs. The glide translation will, the glide reflection will take it below, handedness gets changed and then translated by C by 2. Again it comes up, handedness changes and we can complete the diagram, space group diagram in this fashion. But now let us do a projection along A, as we had done here. So, I have my B vector here, this is a projected C vector and this is my origin here. So, my glide translation or rather my glide plane is parallel to the AC plane. A is coming out. So, therefore, my glide translation so this is how the glide will show up in this perspective and glide translation is along C. So, then I think that is fairly simple. I think you can fill the motifs yourself in this quite simply. Similarly, if I were to project along C, so if I were to project along C, I will have and A and C do not make 90 degrees. So, when A gets projected it will be a projected length. So, we represent it by A sub P. Now, where is the glide plane? The glide plane is parallel to AC, basically which means glide plane C axis is coming out and the glide direction is also C. So, to indicate that, going back from the previous thing that I had done in this lecture, it could simply be that the glide will have to be shown by as a dotted line. So, this becomes a glide and you can fill in the motifs yourself. So, with this discussion on glide and the previous lecture we discussed on screw, I will stop here, and in the next lecture we will have a relook at the international tables. We had seen the international tables earlier for plane groups, now we will look at the international tables for space groups. Thank you.